Welcome to the session from the DataMark Public Safety Virtual Conference. Today we have Spatial presenting Sheila Stephenson, who's their CEO, and Melissa Ubaldo. Did I pronounce that correctly?
Yes, you did. Perfect.
Engineer with them, and they'll be talking to you about providing an effective gateway to enforce data governance. Just a couple housekeeping items as we get started. We are recording the session, so for quality assurance purposes, we've muted everyone. At the bottom of your screens, you have a QA button. So if you click on that and you have a question you'd like to submit, you can do that through that function. I will collect them, and Sheila and Melissa will be answering your questions toward the end of the session. I will hand it over to you for introductions.
Okay, great. Thank you, Jason. As Jason said, I'm Sheila Stephenson. I'm the CEO for Spatial Inc., and I am joined by Melissa Ubaldo, who is one of our primary SEs. And I think we'll just jump right in. We want to talk a little bit about data governance today. And it's obviously something that's on everybody's minds. And we have an effective method for actually enforcing data governance that we'd like to share with you. So there we go. Perfect. Thanks, Melissa. So as I mentioned, data governance is on everybody's minds. I can't hardly get into a conversation with somebody about data and the word governance doesn't come up. And so it's really brought two things to mind for people. Number one, what is the desired state of your data? You obviously need your data to meet your business requirements and to help you do your business and to make good, solid decisions. But if we look at what is the requirement of your data versus what is the current state of your data, we find many people today just aren't really sure about the current state of their data. First off, do they even know fully what are the business requirements? They may know the business requirements for their own needs of the data, but nowadays data is being published out there for so many other use cases. Does it meet those use cases as well? And what's the liability if it doesn't meet those use cases? Further, not knowing what the status of your data is can lead into all kinds of challenges, leading to poor decision making, not being able to meet requirements or statutory requirements. So really understanding both these things is really critical today with as much data and intensive society we've become. So next one, Melissa. And I love this slide because it's very interesting because there's multiple types of consequences for having issues with your data or having poor data quality. And obviously financial comes to mind. And actually, if you look at the other types of issues that come to mind, they can all tie back to financial issues because if data is not accurate, then it can cause delays in delivering services. It can cause productivity issues where people are having to spend time trying to understand, is this data right or is it wrong? And where can I find good solid data? And then they lose confidence. If you're the steward for the data and you're providing it out to a number of people, you find that over time that people will start to say, well, I can't really depend upon that data. It just doesn't have the quality that meets my business requirements. And probably the one that to me is the biggest is the one on the end, is the risk and the compliance. So much data is tied to being compliant by whether it's a government standard or just a business standard. And if your data isn't compliant, it can often cost you in terms of funds. And even more so, it can cost lives in the case of like emergency management. And IBM did a study when they were looking at the value of big data. And I found this really interesting fact that over $3.1 trillion a year are lost due to the consequences of poor data quality. And there we go. So, and as Jason mentioned, we are Spatial, and we have spent our entire life looking at just developing data management solutions to help solve the problems of poor data quality and help people better understand those two questions that are on everybody's minds about what are the needs of my data, and does my data meet those requirements from a quality standpoint? While you may not be as familiar with us over here, because we've only been over here in the US for about 6 or 7 years now, when we got our first effort with US Census, we have been in existence for over 50 years in the UK, where our parent organization, One Spatial Group, develops our One Integrate automated rules engine that helps with doing automated data management. In a moment, Melissa's going to talk a little bit about the three, what we call kind of pillars of data management that we focus on. But they fall into a few different buckets. And as you can see, while 6 or 7 years ago, we had one primary client in the US Census, today we have over 40 to 50 and growing, and utilizing our automated rules engine for doing things like automated change detection, also conflation of data, being able to move attributes and or spatial accuracy from one source of data to another through an automated process, and doing automated QA, QC of the data and understanding the validity of the data, and then being able to use the same rules engine to do automated cleanup. And so we have a wide variety of government entities at all levels, from the federal, where we have Census and Federal Highways and NOAA, and then down into state level, where we're doing spatial data infrastructure projects with a number of different states, and then further down into the county level, looking at working with like Cuyahoga County and LA County, which Melissa will be talking a little bit about today. But I also like to point out our work with Google, and that is on non-spatial data. So it's one of the keys about our rules engine is that it is data agnostic. And so in the case of Google, we help them validate their computer-aided drafting data, as well as their asset management system, which is an IBM asset management system called Tririga. And so our rules engine can work through and across all the different enterprise systems throughout the organization to make sure that your data is steel-threaded and accurate and in alignment between those different systems. So I'm going to pass it over to Melissa, and she's just going to spend a little bit of time on a couple more slides, but more importantly, we'll spend time showing you some of our efforts with some of these clients, as I mentioned earlier. So all yours, Melissa.
All right, thanks, Sheila. So before we go ahead and run through these demonstrations, I do want to mention the rules that we have for Spatial Advantage, because of course, to develop different data management solutions for each and every single one of those projects that we've done so far. And obviously all of those clients have, very different business requirements. We applied a rules-based approach to them using a software that we have called One Integrate. It is a highly configurable rules engine that lets you author your business rules. And what it lets you do is validate your data by finding anything that fails your rules. It can allow you to connect across the entire enterprise and actually write rules that integrate your data with other data sources that are supposed to be maintained synchronously. And it also lets you write a rule to automate how you want your data enhanced or how you want your data fixed, so that the next time that you run that data through the same data validation rules will actually end up conforming to the data quality standard that you've set. And then as you're thinking about these capabilities and how much your data can actually benefit from a process like this, what I would like to preface this is to acknowledge how challenging it really could be to decide where in your current workflow a new data quality tool like One Integrate or One Data Gateway might be most painlessly introduced. This need to have your data quality tools actually be able to work with your current GIS and geospatial systems is precisely why One Data Gateway has been developed a solution. So let's look at what One Data Gateway is. It is part of our location master data management, or MDM suite of products. It is a self-service web portal that is built on top of One Integrate's rule engine. It performs the data validation, data processing, and data enhancement. It's a smart, simple, and controlled way to share your validation rules and data enhancement processes between internal and external users. So what I want to do is do a quick animation for you to show you what we're about to do. As an example, let's use Next-Gen 911 rollup that we are currently doing for the state of Maryland. So because we recognize the need for cities, counties, and states to meet the NG911 deadline, we help facilitate it. So we developed a set of rules specifically based on ANINA standards. So I'd like to briefly go through what the state of Maryland has implemented using Data Gateway to assist their counties in getting their data 911 ready. So currently, Maryland hosts the NINA rules on their server, and they actually ask their counties to submit their addressing data to them by following a few simple steps on Data Gateway. So they want them to upload that data up to Data Gateway, which is this one that kind of looks like a wall there with a filter. If there are any kind of issues in your data, the portal provides those statistics, and you can definitely download those results to identify where those issues are actually occurring in data that you just submitted. It gives you an opportunity to clean it, and then once you've cleaned that data, you can upload it again. And if the quality is at 100% conformance to the rules that was set by the state of Maryland, One Data Gateway then also allows you to automatically deliver that data to the state. So it has effectively automated the Data Gateway supply chain. For the following use case demonstrations that I'm going to show you, we're going to take a look at how One Data Gateway can actually be implemented at various states in a workflow. So the first one I want to look at is for LA County. LA County was facing massive addressing issues, and with the data that they have that's representing a population that's large enough to be the 7th largest state, if it were a state, manually combing through and looking through inconsistencies between their address points, their roads, and their buildings, as well as their parcels would actually is actually not, or would be next to impossible. It's just not feasible. So what we're going to do is validate a sample of their county-wide address management system, or CAMS data, and actually see how we can best coordinate any of these mismatches between them based on their spatial and attribute relationships. So before we look at Data Gateway and how we actually use that, let's take a look at the data that we're dealing with here. So I have that data pulled up here in ArcGIS Pro. The expectation here, we're seeing where our address points, our street segments, and buildings. We also have parcels in there in the city boundary that contains all of it. The expectation here, and the one I really want to focus on, is an address point has to be inside a building, and both of them have to be inside a parcel. And if these spatial relationships hold true, then they should also have similar, if not the same, address information as well. So we're going to go ahead and submit this data that we're looking at and submit it to Data Gateway on behalf of LA County. All right, so LA County, sorry. So, before I log in here, I just wanted to mention that One Data Gateway is available in the cloud or on-premise, and what I'm using right now is running on my local. But let's just say that this One Data Gateway instance is sitting on LA County's server. So after logging in here, I can see that LA County has authorized me to provide data for Lancaster, Palmdale, and West Hollywood. But what we're going to look at first is the CAMS input data. So this is the one right here that allows me to make a submission for the CAMS input data. So I'm going to go ahead and click and drag. That's this one right here. A zip file of my data, which is file geodatabase. So while waiting for that to upload, here it is.
And Melissa, you might want to let them know what CAMS stands for.
Oh, yes, it is, I did mention earlier, it's a county-wide address management system, or CAMS.
Yeah, perfect.
Thank you. So for before we start running our rules, we do also obviously want to make sure that the data that we're submitting is what we meant to submit. So we're seeing here, we are submitting the parcels, the address lines, the building outlines, address points, and the city jurisdiction boundary. It also gives us an opportunity to ensure that we have our complete schema that's being translated across. So I'm going to go ahead and scroll all the way down here because there's a lot of that in there. I'm going to hit save and continue, which essentially kicks off, or which does kick off, the processing session that exists or that was set up by LA County for me to run. So a session, which I mentioned, is what we call a list of tasks to make up a workflow within One Data Gateway. Also mentioned earlier, I'm not sure if I emphasize this enough, that One Integrate is actually the rules engine that's running under the hood here for One Data Gateway. We're going to take a look at that in a little bit. But the session here, a session always has to start with opening or reading the data in. And then once that data is loaded, we're seeing how many features are processing or being read in. Once our features are read in, we're going to go ahead and run them through a series of rules right here. Some actions as well, which are rules that change or make changes to the data. And we're going to try to fix our address points as well, and then try to export out those results right there. So let's give this a couple more seconds here. It's taking a little longer than it did earlier. All right.
Probably bandwidth at this point.
Probably.
Everything seems to take a little bit longer than.
Yeah, we have passed the minute mark. That's strange. All right, here we go. So it's finished reading in all that data. And the first set of rules that it's being pushed through in here is, I don't know if I can span it on yet, is a set of rules called the essential geometry checks. And these are meant to run against all the data in my, that I push in. And they've been written generically. So I didn't have to write, or we didn't have to write a single, we didn't have to write a version of every single rule for each of these classes just to run that same rule against it. We'll see that in a second as soon as I'm able to expand this out right here.
Melissa?
Yes.
While we're waiting on that, there's a question that's come in, and I think I can go ahead and just answer it.
Sure.
Well, unless you want to continue to see.
You can go ahead.
Yeah, so the question was asked is, would One Spatial's conflation capability be useful for meeting the new NENA 1 to 5,000 accuracy guidelines for road centerline data? And yes, that's really interesting. We're just about to start a project with the state that we will be assisting, because using, as I mentioned in the introduction, our conflation capabilities, we are able to realign data that may not be as accurate with more accurate data sets. So whether it's a publicly provided data set or a private data set where people have spent a lot of dollars to create a much more accurate spatial database, you can utilize that. Or it can do things like what we have is called positional accuracy improvement, where we may have GPS points that we can align to. So there's a number of ways that we can utilize the rules engine to help meet that $1 to $5,000 accuracy requirement.
All right, thank you, Sheila. It looks like this is just about to finish. That's perfect timing. But before we go any further, I wanted to make sure we all look at what kind of rules are actually being run against this data now that it's loaded in. So the first set of rules, again, is the out-of-box set of rules that we call essential geometry checks. So again, for this check for duplicate features, it is running against all approximately 40,000 features that I've brought in here that we've loaded in. And again, it's all running, these rules are running on every single feature that got read in. Our second set of rules here are ones that look at roads, and these are, oh, actually, I should mention the conformance rate first. So after a rule has finished running, we're seeing here how well our features did. So anywhere that we're not seeing 100% conformance there, it means that we do have issues in that data. And this session right here has actually been configured to report out these non-conformances. So it looks like we do have duplicate features, we do have spikes in the data set. The second set of rules here are meant to look at the relationship between roads, how well connected they are. So we're making sure that none of them overlap. There's none that's too short. Roads don't contain another road. There's no overshoots and undershoots, very helpful. And we're checking that for any time that roads actually intersect, they're intersecting at their ends. This might be valid, of course, for routing networks. Obviously, they're not going to break at every single point of intersection, but for the CAMS data, they are saying that it should intersect only at the start or end. We have a couple of rules here that also look at attributes. In the first one, we're basically just saying that a road has a name. The second one says that the road's left and right zip code should be valid. There's actually a range of valid zip codes that were written down for that. Next set of rules here, the ones that actually look at the interfeature relationships between our address points and our buildings and our parcels. So for address points, we want to make sure that, number one, they're not duplicated. We want to make sure they're unique. We expect, again, every address to be inside a building. If it is within a building, we're expecting there's only a one-to-one relationship between an address point and a building. We also want to make sure an address is in the correct city. We repeat that same expectation between address points and parcels. And we're saying that there has to be only one within a parcel. And if it is, they have to have the same address information in there. And what I want to show you here as well, before we jump into the results, is we ran some rules here, which are basically our actions here which are what we call rules that actually fix up our actions or fix up our data. So we have one that removes our duplicate points. It's supposed to clean it out. An action to remove the spike. Our build topology task here is actually what fixes the alignment in our data, which is what Sheila mentioned earlier. It is a built-in process within the engine, and what that's going to do is get rid of our overshoots and undershoots. To address our address points and our buildings, we are going to create a proposal to where these address points should be mapped to a building, or we'll try to assign a designated building to it. And then we're eventually going to apply that proposal and move the address point to a nearby building. We do the same, again, for address points that are outside parcels. And last but not the least here, we're going to update our proposal status. Another last thing I want to show you here is that we reran this rule here that checks for address points within a building. And what's nice is after rerunning a rule after running these actions will give you immediate real-time results, because now you're seeing how well your actions that are supposed to fix the data up actually went. So right now we're seeing the conformance rate for all of these address points that are within the building. We have it at 84.59%. When we ran this earlier, address within building, we had it at 76.02. So obviously we had a climb of 10% there, give or take, approximately.
Go ahead. No, go ahead, Melissa. Go ahead.
Okay. So for this last part here, again, we were able to also export out or copy out all of our updated data sets. So now this has been enhanced data, and we're seeing that we also have our proposals in there as well. Once I hit finish, and this is what's nice about One Data Gateway, is I can download the output files in here. And if you have to submit some kind of documentation, it also auto-generates a report over here. Actually, let's take a look at that real quick.
And while she's doing that, I wanted to point one thing out is, as Melissa, even though Melissa's not patient, so she didn't want to wait for the 40,000 features to finish in just a few minutes, but you might have noticed that it was 40,000 features that went through a number of different validation checks, as well as some manipulations to the data, as well as some proposal creation, all within just a few minutes. So one of the key features about the One Integrate is that it operates in an object-oriented disk cache. So it enables that really quick feature-to-feature comparison, and also deals with really large data sets and handles it with any issue.
Perfect. Thank you, Sheila. I did kind of get impatient with it. And I just really have to admit that this usually does not take that long. I think it's a bandwidth issue. I just want to point that out. So the auto-generated PDF file that we have here, which is a report that's produced by One Data Gateway, actually gives you all the statistics or different kinds of metrics that was produced from running your data through that entire session. So how many features were actually brought in here? How well did our features do when we ran these rules? And all that good stuff. So what I really like about it is it's very appropriate. It does look like a nutritional facts label because it does show you the health of your data as you're running it through here. So again, all that nice info in there ready for you to share or submit. All right, so let's take a look at our results here. We're gonna go through some of our bookmarks here that I've pre-marked. I've also brought in the markup points, which are the point us to the non-conformances that were produced from that session. So we do have a duplicate feature found in here, and all this rule said, again, because it was generic, was essentially saying that I can't have another feature sharing my geometry if we belong to the same class. Very, very generic check. So in here, we do have two sheet segments that share geometry, but obviously we have different names. We can absolutely reconfigure the rule to be a little more specific and say for roads that have the same geometry, don't count us as duplicates if we actually have different names. So actually, there is a rule there for the address point. We'll look at that in a bit. We're also seeing the same ones here for parcels. Again, this is from the generic rule run. So we're seeing that these duplicate features have been found here. And notice how these are all right on top of each other. Even if some of them have the same site house numbers, they do have different site units. So one of the things that we can do to reconfigure this rule is to say not only look at the property house number or the main number, also make sure that there's none with the same site unit.
So and that's a good point, because a question just came in about how are multiple address points in an apartment building or single building dealt with, and that's exactly how you could do it, is work with those other fields that would give more definition to it.
Correct. You can make it as specific as you want, because really you are supposed to have every single one of these match up because they are supposed to be the same thing. But obviously you're the only one who really knows how your data is supposed to behave or how it's supposed to look like. So in this instance, we didn't reconfigure it that way. So these might be valid duplicates. And actually, we do have an example here for duplicate address points. We have one right on top of each other right here. They do have the exact same geometry and the address information that we asked, or that One Integrate was asked to look at, which is the number and the street name. All right. Let's move on to another essential geometry check. Over here, we found a spike. And what I want to show here is how big this building actually is. For most third-party validation tools, a software wouldn't really be able to pinpoint exactly where a spike or a kickback occurs. And what's nice about One Integrate is there's actually a built-in function within the engine that pinpoints you to the exact vertex that's causing that spike or kickback to occur. This is near impossible, especially for the folks over at NOAA who we share this with. Definitely do appreciate that they don't have to crawl through the coastline anymore to just look for that little single vertex right there that's causing that error. One of the things I do want to mention is for a lot of people, and I know that I experienced it because I do used to work on geological charting, the frustration would actually lead you to just delete the entire thing and redraw because you're not going to spend an hour looking for that vertex. So by having a tool like this, it definitely saves you so much time and effort.
Well, not to mention if you're breaking protocol when you're not supposed to redo it because you would lose all that wonderful metadata.
That's right, exactly. Oops, I skipped some of the roads right here. So we also have roads right here that are overlapping another road. Just flip through them real quick. This guy right here completely contains another, or overlapping. Here's the one that says that our road should not intersect at end. I'm not sure if I wrote that. So for this street segment right here, because it is intersected by this other street segment, usually you would expect 3 separate segments for this line right here, but instead we're only seeing 1. So again, if depends on your data, if it's a route network, then that's definitely not a non-conformance. But for this CAMS data, it is. Oops, sorry about that. All right, more of the connectivity issues that we have. So in here, we do have an overshoot and undershoot, or an undershoot in this sense. So all the rules said there was that if the start or end of a road is within 5 feet of another road, then we expect that start or end to actually be intersecting it. And what's nice about One Integrate also is that you can tweak that parameter. Right now it's written at 5 feet because we're seeing here this one is just at one feet away from each other, 1 foot away from each other. If we check another one, again, our parameter right here is 5 feet, and this one is just right under that. So this this guy right here also got flagged as an overshoot. We'll move on to some non-conformances with the attributes. With attribution right here, all our rules said for the road names is that a name cannot be equal to null, and we're seeing here that this street doesn't have a name. Again, you can absolutely reconfigure the rule to say if there's another attribute value in here that says it's a driveway or it's a private, it's a parking lot, then definitely it doesn't really have to have a name. So you can definitely configure that rule to make an exception for those scenarios. Another one right here, zip codes. So the rule says that the zip codes left and right have to be a value, obviously a positive integer, in the range of 90,000 and 95,000. And what I want to point out here is because the rule was written that way, in a positive language, we're actually able to see that we were actually able to find these 2 nonconformances here. Our zip code right here is null, and for the other one, it's a zip code left that's null. So we wrote it, the rule was written in a positive language because obviously it would take you a million years to write out how many times or how many different ways a person can mess up typing something into a field, especially in a field like this one. So by writing it in a positive language, of saying that the only acceptable values here are positive integers, null ones or any ones that contain empty spaces or special characters, all of those are going to get flagged by just saying that this is the positive way that this rule is going to be written. It has to be a positive number between 90,000 and 95,000. All right, let's jump to more exciting stuff. For the address points outside of our buildings, this check only simply says that the address point has to be contained within a building. And obviously we're seeing here that these 4 address points are not contained within a building. This guy here got flagged because we also wrote a rule, or there was also a rule that was written that said a building has to contain exactly 1 address point. So we select that address point right here, same number, but different street names. Moving on right here to the parcel, same rule. Same type of rule, we're checking that parcel should only contain exactly 1 address point. These ones all have duplicates, one right on top of each other, very similar to what we just saw. And last but not least, address point number doesn't match our parcel address, even if it's the only one that's contained within it. Or actually, so let's actually check this one right here real quick. This address point is for Columbia Way, but this parcel, or sorry, the number for this parcel, or the site unit number here is 2040, sorry, right here. But the address point is 2038. So that's definitely a non-conformance to that rule. So because we've also run our fix-up actions, I'm gonna go ahead and show you the updated data. And let me just turn off our old data right here. So now we've seen where our data was conflated. Let's visit some of these non-conformances that we saw. The spike right here. Oops, sorry about that. Spike right here no longer exists. The build topology task did snap our undershoot right there. And let's see, the overshoot. The overshoot was not fixed. That's because within the LA County session, it says only automate the fixes for those undershoots or overshoots that are 3 feet or less. So there's definitely that that opportunity, or that customizable tolerance that you can tweak to say how far would you want to go to automate some of these fixes. One of the things that I always want to mention with people is that even if you have a way to automate a fix, you wouldn't want to overfix. You still want to control how much of the data you're actually fixing, because overfixing can definitely lead to more errors, and you can actually end up deleting a lot of stuff that you don't mean to. So just kind of a little thing that we always want to keep in mind.
We usually try to shoot for somewhere in the 80 to 90 percentile range, though.
Yes, that's right. All right, so let's take a look at some address points that are outside of our buildings. So again, using that, in that session, we were creating proposals for any of these address points that are outside of their buildings. We're seeing here that of all 4 of these, it's only this guy right here that actually had that proposal. And that's because the way that the proposal writing action was written was to say that there has to be a one-on-one relationship between the address point and the building. And the reason why that was written is because we can't really determine which one of these 2, for example, this address point belongs to. Same for these 2 scenarios right here as well. So we just made a determination that the easiest way to do this, for at least this first round, is to look for, only apply the ones that have a one-to-one relationship. And what I also want to mention here is for the address points that were moved, here we're seeing that so the markup point right here, which we did move, our building information here says this is my building ID, this is my building code. We went ahead and conflated that data over to our address points. So now the address points that are contained within that building would actually have coordinating attribution in there as well. So we're saying here that this is the ID I belong to, this is the type of building that I'm sitting in, and just as an extra in here, we just said that this corrective action came out of One Integrate's actions. Another one right here, actually let's take a look at some of them. So we're definitely seeing where a lot of these address points were moved versus where they have not been. And let me zoom in right here real quick because I want to show this to you. So even though that one-to-one relationship has to exist between a building point, an address point and a building footprint, this looks like that does meet that criteria, but I said we both have to be contained within that parcel. And if you're noticing right here, this is overlapping over to that other parcel, which is why the parcel. So a proposal was not created to move this address point into that building, because both of us aren't completely contained within that parcel. Another one I like to point out here is, again, we're seeing that this is not a one-to-one relationship between the 2, but obviously you wouldn't want to drop an address point on that smaller building. It might just likely be a garage or something else. So obviously this might be the main house if this is residential. I do get asked a lot if there's a way for you to actually look for the biggest building and then match it up. Absolutely, there is a way for you to set up One Integrate in such a way that you query all the buildings that contain that this address point and actually look for the biggest one. So that would definitely we can add that reconfiguration in to correct this even further, or to make it a little more consistent, because obviously you don't want to map it to that little guy right there.
And that leads to a point of a question that's, can we weight the proposals by how confident you are that a given building is the right building? And so certainly that could come into part of that weighting. And as a matter of fact, in our work with US Census, that's exactly what they do, is that they weight the proposals that are suggested by One Integrate, and if it meets whatever their percentage confidence level requirement is, they then will automatically ingest, this is in their Map Tiger work, the master address file and road center line for the United States. They will automatically ingest those updates to the Map Tiger. If it doesn't meet those the percentage confidence, then they go into an automated manual, semi-automated review process.
Right, and actually I do have an example for the change detection a little bit, where we do end up calculating some spatial confidences as well as attribute or scalar confidences.
And
Before
just
we
being
move,
cognizant of time, Melissa, you've got about 20 more minutes.
ooh, all right. So before we move away from LA County, I do want to show something else. So what if we wanted to make multiple submissions for LA County? I don't know if you noticed earlier, but I have more than one. So what I want to show you here is how One Data Gateway can also be helpful for getting information from multiple submissions. So again, we have one for Lancaster, Palmdale, and West Hollywood. I submitted these this morning beforehand, but what I want to look at is this dashboard that we have here. It's pretty comprehensive behind the One Data Gateway. If you look at the specification of the project, give me 1 second to look at it real quickly. We are seeing statistics here, the top violated rules percentage. You can see trends on which rule a lot of these submissions or jurisdictions are actually failing. And we're seeing it's the PSAP rule right here. We're seeing how many deliveries are made over time per jurisdiction. I made a lot yesterday and today. And this morning, we're seeing also a trend of how the qualities either improves or does not improve over time. So it's really nice for on the back end for LA County to see how well their jurisdictions are actually conforming to the rules that they've set up. So obviously that could help in implementing better rules or maybe further education in what these rules are meant to spot or how your data is supposed to look like to correct it. All right, so I did mention One Integrate earlier, and I said it is the engine that's running under the hood of One Data Gateway, so let's go ahead and look at that. So this is One Integrate. I am on the sessions task right here, and this is what we saw run for LA County. For the CAM submission, we're seeing here, again, open data task, all the rules and fix-up actions that we have, and we also copied or exported out that data. So again, a session always has to start with opening a data and opening a data set. And what I want to point out in here to show you, Sheila already mentioned that One Integrate is data agnostic, is all the other different options that you can use to set up One Data Gateway for your data submissions. CAD, obviously, it's right here. We also have flat CSV files. You can connect to an enterprise view database. If you have connection information for your SQL Server, your Oracle, we can read that in as well. So you're definitely not just limited to your most frequently used Esri file view database and Esri shape. And what's nice about that is when you read these in through One Integrate, you are given access to, again, the entire data set in here. And it brings in the schema as well. And what I wanted to point out here is this is important because as you're writing your rules, you definitely want to make sure that your rules are 100% compatible to your data, right? So right here, what's nice about One Integrate is let you use sample data to read it as a context. And I've selected it here for the LA County submission. We don't have to look at that, but I turned it on. So right here, we're seeing I have all my classes that were not dragged in here, that were loaded into One Integrate. And I'm also seeing the schema has been brought in for that as well. So it's kind of like a fail-safe rule writing in here. You do not have to hard code anything. And just to let you know, I've been using One Integrate for at least 5 years. I do not have any programming background. So for me, this was a pretty easy Sesame Street approach to programming.
That's good.
All right. Okay, so actually, before I do want to move on to the next one. So we've seen that we can actually process data from different sources of data. We're pulling in here CSV data and the shapefile to process data for Cuyahoga County. And the scenario here is that, or what they were interested in doing was making sure that these two data sets are in sync, even if one is sitting in a CSV and one is a shapefile. So what we're going to do here is submit a shapefile that's being submitted by the GIS team of Cuyahoga County and automatically access the CSV that's sitting in the session that's been set up in Data Gateway. So let's go ahead and make a submission for Cuyahoga County.
And while you're doing that, I'm going to mention also, you mentioned that the One Integrate underpins the Data Gateway, but One Integrate also underpins Michael Baker's VEP product, where it's utilized to do the validation of the data, provide the results back to the end users who then use the VEP tools to do the updates to the data.
That's right. All right, so very similar in here. Once it starts running, we are seeing two separate open data tasks, and that's because one is accessing the CSV, and one will be accessing the Cuyahoga County GIS parcels that I just dragged in to submit for Cuyahoga. So we're going to see the same types of rules. What's important here is to make sure that between these two data sets, if they have the same unique parcel PIN ID, we have to have the same information in there for your parcels. I'm going to go ahead and jump in here because I know we are stuck in time. So let's take a look at nonconformances. So let me look at nonconformances right here. I copied out those markups. Oops. So the data synchronization says that one has to exist in another, and the real world consequence here is that if some of the records that sit in GIS parcels does not exist in the CAMA, then there must be some of these parcels that they're not collecting revenue from, right? So that's loss of money for the county. So right here, this parcel PIN number right here says that it does not exist in the CAMA table. And if you take a look at the CSV super duper quickly, this one ends in 3006. It jumps from 30058 to 3009. So obviously that number, the parcel PIN number that's supposed to be unique does not exist in the CAMA side. All right. Oh, CAMA, by the way, is
the loss of revenue that we talked about earlier by having poor data quality.
Correct. And I did fail to mention what CAMA meant. It's a computer-aided mass appraisal. So most of the time, all these counties still do maintain them in CSV files, which is why I thought this would be important to show. Another type of synchronization issues that they have is on the CAMA side, if it's empty, the grantor right here was null value, but on the parcel side, they are typing it in as n/a. So it'd be nice to know how, or try to be, it's hard for a lot of these organizations, of course, to kind of be, to have a uniform way of filling in these attributes, but you can obviously reconfigure one integrate to count n/a as a null, and therefore these should be the same. For what Sheila mentioned earlier, and what one of the questions was interested in is how we can actually write up a score or some kind of matching score between multiple data sets. And what I wanted to show you or point out here, let me turn off actually those corrected parcels just yet, is that when we were matching these CAMA entries in, we were looking at a match score, and one of the built-in functions within one integrate was actually in calculating a Darrow-Winkler similarity, sorry, Levenstein distance between two strings, which is what we use for here. So our CAMA grantee says it's Snyder, Gerald R, but on the parcel side and GIS side, it's Snyder, Gerard R. So the match score here is 1 because it does count how many letters or characters, I'm sorry, are actually different between the two strings. So in here, we're the autofix here is to actually update the parcel side to match the CAMA. And I've uploaded that here. I brought it into ArcGIS Pro. And we're seeing that before our grantee is Snyder Gerard R, we corrected it to say Snyder Gerald R. So we definitely were able to kind of conflate that data and make sure that these match up, so that next time I run the same synchronization rules, this parcel right here is no longer going to fail.
And you can set to whatever is the more authoritative data source for you. So in that case, oftentimes the CAMA system is considered the most authoritative with regard to taxing entities. And so that's why they went with that. But if you know that your GIS data is much more accurate, you can use that as the authoritative data source.
Yes, absolutely. We did make the assumption for them, because they didn't tell us which one should take authority, that the CAMA should be the one that actually has more accurate grantee, grantor, for example, information in there, as opposed to the GIS side. Last but not the least, we're running it tight. Another way to resolve some of the data sets that are out of sync is by applying a change detection process. And in the case of Collin County, they were receiving updates from their local jurisdictions, and what they used to do was simply pastry cut and replace some of the road data using their city boundaries and essentially just stitch the data back along the edges. They were spending a lot of time manually doing that cutting and replacing and edge matching each and every time there's a submission. And like what Sheila mentioned, when you're getting rid of data like that, you're definitely losing a lot of metadata and history as a process continues. So blowing that data away and replacing it does seem like an overkill solution to roll out updates, especially since for the most part for these roads, you wouldn't really see dramatic changes on road networks anyway. So they've asked us to help them come up with a more efficient solution, which would be to deploy a change detection process instead and pull in your old and new data together, run them through some rules that narrow down where and how they are different, and create proposals for those changes, and then automate applying them as well. Another processing hurdle for Collin County that I do want to mention here was having to deal with different schemas. So I'm sure it's common for a lot of cities and counties as well. They don't have a standard GIS model for their roads, which is why a pre-step here that we're seeing after the input data, or in between input data and change detection, is pushing the data through a set of schema standardization rules. So we're going to use one data gateway to again make that submission. It's Collin County right here. Again, we are clicking and dragging. I'm not going to wait for it to run anymore. But I'm just going to go ahead and hit the play. So let's go ahead and look at the results that we have here. I brought them in. So we are only looking at McKinney jurisdiction. And the goal here really is to determine how different these two data sets are. Oops, sorry, right here. All right, so for this data set right here, what we want to do is, if there are no changes found between the two, first of all, we determine how they're interacting. Are we spatially the same? Do we still have the same bearing? Do we have the same address information, etc., and all that good stuff? If none of these changes are found, we're going to create match proposals. If the geometries match but have different changes in differences in attribution, we're going to create scalar change proposals. If there's slight changes in geometry, we're going to create a reshape. If a road wasn't there anymore, we're going to add it in. If it's not there anymore, obviously we're going to delete them. So let's go ahead and look at our schema standardization first. Let me pick a random road right here. All right. So we're seeing here that the addresses are currently being stored by Collin County as LF_ADDR for left address, but it was submitted by McKinney to be L_add from. So obviously it would make it so much easier to do that comparison if we actually had a standard schema. So the first step again was to standardize that schema. So let's go ahead and flip that over here. So now we're seeing that our LF_address is true for both schemas. All right, so now that we have those, again, we created the proposals. So let's visit some of these proposals. Scalar attribute. Again, for a scalar change to a scalar proposal to occur, it means there's a change in attribution. So initially, or what Collin County currently has this road as is County Road 148. But when it was submitted by McKinney, it became CR 148, was shortcutted. So we were saying that there is a scalar change between these two roads right here. Next up, let's look at a reshape proposal. Again, if there's only slight changes, we're going to create a reshape. For here, it will look pretty obvious. Road space is what it was before. Now it's submitted to be this blue standard, this blue jurisdiction, new updated jurisdiction data. So this proposal right here to extend that out is a proposal to reshape it, to just extend it. So now these are going to look the same. 355. Let's look at some proposals, some more proposals here. Obviously for the deletes, don't really have to go that far through that ones. And just to show you some of how you can actually manipulate one integrate, or how specific you can get into narrowing down these proposals is saying how far or the distance in which these networks are shifting. If they are shifting consistently by however much, you can absolutely configure one integrate to say, even if it's only far apart by this much, or the bearings barely changing, we are going to go ahead and have these out as match proposals. Because of the way that these rules were written, we're seeing that these have been counted as lots of adds and lots of deletes. So again, that reconfiguration is definitely up to you, or can be done by you. All right. All right, so to kind of, I guess, wrap up, what we've done through One Data Gateway is we've submitted data to test some of these validation rules against them, and we actually received those instant feedback results. Oh, I forgot to hit play on my animation. We've also seen how it can ensure that the submitted data doesn't pollute your master data by only delivering that data that meets the business rules that you had in place. And we've also seen how it can actually roll out updates to enhance your data and keep it current, like what we've seen with the Collin County. And all of these steps definitely promotes data interoperability, which is really the core of having effective data or having effective data quality management processes. So you want it to be an ongoing process of collaborative data sharing. And as long as you understand, like what Sheila mentioned at the beginning, what you need and what the purpose of your data is, you'll be able to determine the standards by which the data needs to be maintained, right? So the rules that need to be followed. Because obviously only accurate data is useful data. And that concludes our presentation. Sheila, did we miss any questions on there?
I think we got the primary ones.
All right. I'm sorry, I cut it close, 3:57.
No, sorry, Jason, we're right down to the wire, aren't we?
No problem. I really appreciate you guys joining us in your presentation. It was very informative, and we'll look forward to any follow-up questions we'll send your way.
Okay,
Thank
great.
you.
Thanks, everybody.
Bye-bye.
Bye-bye.
Bye.